Hello and welcome to part 6 of my SPSS walkthrough. This time I'm going to be doing regression analysis, which is all about essentially making predictions using the data that you have available to you. Essentially, you're going to be finding out what your independent variable is and then making predictions as to what the value of your dependent variable is likely to be. So I've gone ahead and I've opened up my SPSS data set rather, and I'm going to show you 2 ways essentially to get most of the regression data that you're going to need. The first thing is you're going to want to graph out in a scatter plot the data that you are trying to visualize, and then put in manually a line of best fit that will also provide you with the regression equation. Okay, so it's a good way to kind of visually represent what your data ultimately looks like. So what you're going to do is you're going to do graphs, legacy dialogues, scatter dot. And you have to bear in mind that this type of regression analysis only works with interval and ratio level data. So you're going to click on simple scatter, and then you are going to place your independent and dependent variables on the x and the y axis. So let's go ahead and look at, let's see, how about AIDS cases. Let's see if that is affected by, how about percentage of the population that lives in an rural area. Okay, so your standing hypothesis can be that if a place is more rural, it's probably going to be more sparsely populated, ergo AIDS rates might be lower in those kinds of areas. I think that's a fair hypothesis to work with. So we got AIDS on the y-axis and rural on the x-axis. We hit OK, and it will plot out that data. Now, just looking at this, my guess would be that it is indeed a random association, but we're going to verify that by adding the line of best fit. You double click the image, and it brings up this chart editor. You don't need the properties here, they're fine as they are. You go down here to where this target is, and you move over to the 5th space, the 3rd one you can click on. It says add fit line at total. You can add the fit line, and it does seem like there is some degree of increase as we go. So maybe it's not. 0.13 for our R square. It's actually, it might be a nice weak association here at least. Possibly moderate, depending on the the relationship there. But this is actually our regression equation that comes from it. So that's y, which is y prime, which is the predicted value of the dependent variable. The intercept, negative 10.22 plus 1.7, the slope times the value of the independent variable that you're looking at. So basically what you could do with this information is plug in a value for x. Let's say 10% of the population is rural. It would be negative 10.22 plus 1.7. So let's see, that would be 11.92 would be your predicted overall rate of AIDS infection. Okay? So there's that way of kind of visualizing what's going on, but then if you do analyze regression linear, you can take your dependent variable, the number of AIDS cases, by percentage of the population that is in a rural area, and actually create this coefficients chart, which again will give you the negative 10.223, which is the intercept, 1.701, which is the slope, but it's also going to give you your standard error. So this is particularly important in that it tells you how far off your prediction is likely to be each time you input your data. So while the visual representation of the graph is fantastic, and I would recommend everybody to initially run that type of regression analysis, you also want to get that standard error in there so that you know basically how far off your prediction is likely to be. Now that being said, you do your analysis of variance here. It does appear to be a statistically significant relationship based on the ANOVA. So, maybe there's something going on here with regard to percentage of the more AIDS in more rural populations. That's kind of interesting. Wasn't expecting that. I was expecting an inverse relationship there. But there you have it. That's basically all that you need to know as far as regression is concerned. You're able to put together your regression equation and then have this standard error value and begin to make fairly accurate predictions about the value of your dependent variable if you know your independent variable.